Hello. So for today's lesson, our learning target is I can write and graph quadratic functions in vertex form. So if you recall from our last lesson, we went over how to graph quadratic functions that were in standard form. Um, so now we're going to learn how to graph functions that are in vertex form and also how to change functions from being in standard form into vertex form. So first off, what is vertex form? So vertex form is the form f of x is equal to a times x minus h plus k, and x minus h is squared. So this is another way we have of writing quadratic functions. So now we want to see what does each variable represent. So a is a scale factor, which dictates how steep the function is going to be, the parabola. So if a is positive, our parabola will open up. If a is negative, our parabola will open down. And recall from last time that in this case, our vertex is a minimum, and in this case, our vertex is a maximum. X is just going to be our normal independent variable. And then h and k represent the vertex. So the vertex is at hk, where h is the x-coordinate and k is the y-coordinate. So you see, one of the main reasons vertex form is really useful to us is because in standard form it's kind of circuitous to find the vertex. First we have to find the axis of symmetry, then we have to plug the x value for the axis of symmetry back into the original function. In vertex form, the vertex is right here in front of our face. So let's go through a couple examples. So if we have f of x is equal to, say, x plus 5 squared minus 3, say we want to graph this function. So we know that since a is going to be equal to 1, our vertex is a minimum, and it will be located at the point -5, -3. So I'm going to go left 5 and down 3, and that's where our vertex is going to be. Now we can find our x-intercepts. So to find our x-intercepts, we're going to set this equal to 0. So 0 is equal to x plus 5 squared minus 3. I can add 3 to each side. And then I can take the square root of each side. So this is using the square root property like when we were completing the square. So we have x plus 5 is equal to plus or minus square root of 3, and thus x is equal to plus or minus root 3 minus 5. So root 3 is somewhere around 1.5, around there. So our x-intercepts are going to be at around -3.5 and at about -6.5. So we have -3.5, -6.5, And our graph is going to look something like this. And that would be how you graph a quadratic equation in vertex form. So let's go through another example quickly. So let's do f of x is equal to negative 4 times x minus 3 squared plus 7. Well, let's make this plus 16. So our vertex this time is going to be a maximum, since we have an a value of negative 4. And it is located at, let's see, so at the point negative 3, 16, or positive 3, 16. Sorry, that's a common mistake. And I will write this graph like this. So we're going to go right 3 and up 16. So this is going to be our maximum. So now if we want to find the x-intercepts, we're going to set the function equal to 0. So I'm going to subtract 16 from each side, and we're going to get negative 16 is equal to negative 4 times x minus 3 squared. Then I'm going to divide each side by negative 4. We'll get 4 is equal to x minus 3 squared. Take the square root of each side. Square root of 4 is plus or minus 2. Equal to x minus 3. So our x-intercepts are going to be equal to 3 plus or minus 2. So it would be 5 and 1. And an x-intercept at 5. An x-intercept at 1. And our function is going to look like that. So those are two examples of how you graph quadratic equations that are in vertex form. But now we want to know, how do we go from standard form into vertex form? So suppose we're given f of x is equal to x squared minus 10x plus 2. So we go from standard form to vertex form by completing the square. So our first step is I would set this equal to 0. We get 0 is equal to x squared minus 10x plus 2. And I'd subtract 2 from each side, just like we were completing the square. So now we're going to complete the square on this side. So negative 10 divided by 2 is equal to negative 5. And then negative 5 squared is equal to 25. So that means we are going to add 25 to each side. So we get negative 2 plus 25 is equal to x squared minus 10x plus 25. If I factor this side, I get x plus 5 squared is equal to 23. Take the square root of each side. We get x plus, or no, sorry. So I was getting one step ahead of myself. So we will factor this side, so we'll get x plus 5 squared. But our work with this side is done now. We get 23, and now we will subtract 23 from each side, and we'll get 0 is equal to x plus 5 squared minus 23. Now we're going to replace the 0 with an f of x again, and voila, we have our quadratic function in vertex form. So make sure you do not make the mistake I did initially and take the square root of both sides once you're in here. We want to leave our equation in this form and then move the 23 over so that we get this really nice vertex form. If we want to graph this, we know that the vertex would be, we'd go left 5 and down 25, and then we could find the x and y intercepts, then our graph would look something like this. So I would just want to go through one more quick example of going from standard into vertex form. So we'll do that right here. Suppose we have f of x is equal to negative 4x plus 12x plus 8. So we're going to start by setting this equal to 0. And now we're going to divide everything by negative 4. So we're going to get 0 over negative 4. I'm leaving this in this form, and we'll see why pretty soon, is equal to x minus 3x. Actually, let's make this a 16. Let's make this a minus 4x minus 2. I forgot to put the squared up there. So now we would add 2 to each side, and we get 0 over negative 4 plus 2 is equal to x squared minus 4x. So we're going to take negative 4 divided by 2, which is equal to negative 2. Negative 2 squared is equal to 4. That means I add 4 to each side. So we're going to add 4, and we get 0 over negative 4 plus 6 is equal to x squared minus 4x plus 4. If I factor this side, I will get x minus 2 squared. This side I get 0 over 4 plus 6. We're going to move over here. If I subtract 6 from each side, we get 0 over negative 4 equal to x minus 2 squared minus 6. And we have one last step, which is the reason I left this negative 4 here, is we're going to want to multiply everything by negative 4. We'll get 0 is equal to negative 4 times x minus 2 squared, and negative 4 times negative 6 is plus 24. Then I'd replace this with f of x. So f of x is equal to negative 4 times x minus 2 squared plus 24. And that is in vertex form. Negative 4 is our a, negative 2, or 2 would be our h value, and 24 would be our k value. So even if we have something other than 1 as our leading coefficient, we deal with it in this manner. So it's really not too bad. So I guess that concludes our lesson on vertex form. And I guess that concludes our studies of graphing quadratic functions. So in our next lesson, we're going to move on to looking at how we can apply these quadratic functions to solve real-world problems. So stay tuned for that.